Hello and welcome everyone. My name is Mark Henry. I'm a senior engineer with opMantic's North American office located out of Charlotte, North Carolina. Today we're going to talk about how to improve your network performance using opFlow to analyze NetFlow and IP-Fix related information. A few quick housekeeping pieces. If you're watching this webinar live, we will be sending out a follow-up email after the webinar with a link to the recording. If you have any questions during the presentation, please use the GoToWebinar chat or Q&A panel, depending on which version of GoToWebinar you have, to send us messages. We'll be keeping an eye on that throughout the presentation, and we'll try to address your questions while we can. At the end of the presentation, there's a short exit survey. If you leave early or if you go to the end and we close up the presentation, it's just 3 questions. Please take a moment and fill them out. For those of you who are viewing this presentation on YouTube, please come to opmantic.com, look for the Learn section. You'll be able to find the downloads for this presentation there. And of course, if you came to the opmantic.com website and you're viewing the webinar there, you should be able to find the ancillary materials. For those of you who are here live today in the presentation, you can download this presentation in PDF format from the handouts panel on the GoToWebinar Control Center. All right, so enough of that piece. What we're going to talk about today is how to really leverage NetFlow and IP-Fix information to really improve the quality of the services and the performance of your network as a whole. So usually when I talk to engineers, they're using NetFlow retroactively to look back in time and try to identify DDoS or intrusion attempts. And that's fine. That's a great use for NetFlow information. It's a perfect use for opMantic's opFlow product as well. But you can also leverage it on the day-to-day and also on a week-to-week basis to really get a feel for what applications are using your bandwidth, what users, what individuals are running those applications, how their activities, how their day-to-day activities really affect your network performance and available bandwidth. And by looking at that material, if you really pay attention to it over a 20 or a 30-day period of time and work on adjusting the way you architect and organize your network, you can really improve the quality and speed of performance dramatically. So we're going to talk about those pieces today. So some useful references for you. Obviously, we have the opFlow section of the opMantic wiki. There's also a community questions board. So if you have questions, if you'd like to find out more about opFlow, post there. Our engineers or one of the community members will get back to you. If you are a supported customer, if you're in the middle of a review of opFlow, email support@opmantic.com. So just very quickly, what is NetFlow and IP-Fix? So NetFlow really is the collection of IP traffic statistics at the router or switch level. It's gathered, it's formatted depending on the version of NetFlow, and we talk about kind of the sequencing of packets in NetFlow version 5 down below. But depending on the version, the order of information, how the information is gathered, how it's processed, and how it's forwarded on change slightly depending on which version of NetFlow. You might hear the term NetFlow or IP-Fix used interchangeably. IP-Fix is actually NetFlow version 10, and it is actually a separate standard from NetFlow. It expands on NetFlow, which is specifically which is specific to Cisco and was defined by Cisco, although it's often copied and emulated by several different vendors as well. But once NetFlow information is collected and organized, there's a lot of statistic information that is gathered. It's information about the interface used, the output interface, so where's the information going to, timestamps, number of bytes and packets, the type of information, what the protocol is, and then some layer 3 routing information, as well as IP addresses of the next hop and the route destination. So there's a lot of really good information inside NetFlow. What it comes down to is is taking that information and presenting it in a way that makes sense, that is useful for engineers. Really hardcore guys, like on our side, we've got a couple of CIEs who they want to look and they want to analyze the actual NetFlow information in raw record state. Other people enjoy having a GUI. You can actually do both with Opmantic's opFlow solution. We're really going to be focusing on the GUI today. So the long and the short of it is that this information is gathered again at the router or the switch. It is interface based, and it can track both ingress or egress information across that interface. And it's all about what is the information, what's the communication happening through that interface on that router or switch, and capturing that information over time, sampling it at some level of detail, and then sending it from that router or switch to a collector and analyzer, which is what opFlow is. So there was a quick question just posted about the presentation. Again, a copy of this presentation is available in PDF format, so feel free to grab a copy either from the handouts panel here in the GoToWebinar, or if you're watching this after the live event, you can get it on opmantic.com right on our website. Go to the Learn section, look for webinars, and you can find this presentation, how to improve network performance with opFlow. So there's often a question posed, how should I collect NetFlow information? So in order to collect NetFlow information, what you do is you simply configure your router or your switch. You tell that router or switch which interfaces you want to collect NetFlow information on, how often you want to collect it, what version you want to encode it into, and where you want to send it to. So what is the collector or the analyzer you want to send that information to? When you're trying to determine which interfaces you want to collect information on, what we often see is we see engineers just say, I'm going to collect everything. I'm going to collect every interface, both ingress and egress from that interface, and that way I just have the information. The challenge with that is kind of twofold. The first is the more interfaces you collect on, the more load you place on the router or switch, right, on the device itself, and that's primarily CPU load that you're placing on that device. The second thing that happens is the more information you collect from those interfaces, right? When you're collecting from a router's interfaces, you'll have kind of a primary in and out interface, and then you've got ones that are routing information to all of your downstream switches. If you're collecting from everything rather than just from the primary interface, what ends up happening is you're going to end up duplicating an awful lot of information. You'll have traffic moving in and out of the individual interfaces as well as the primary. So generally speaking, when you're looking at like a hub and spoke network, like what you see on the screen now, what we talk about is understanding what kind of traffic is important to you. Apologies. So for example, if you're interested in seeing the traffic from Melbourne that's going through the router and then out to the internet, of course you want to monitor it here at the router. If, however, you're interested in more VLAN information, maybe information that's moving here locally, or if there were to be a router here, and I apologize for not having one in this place, information that might be moving from an additional device through another switch and then back around again, you may want to be able to capture information at this level. Having it here at the main router simply wouldn't do you any good, of course. But the concept at the end of the day is to only collect information from interfaces where it makes the most sense. So for example, if you had a NetFlow capable router here on this switch, or rather a switch, you'd want to monitor this interface perhaps heading out of the switch and heading upline. You could also monitor an inline leg from another switch. So if you had another switch on this side as well with more devices downstream coming in, you might track that leg as well. So it really comes down to understanding what makes the most sense for you. and where devices are getting information from, and where you're having your challenges on bandwidth usage. When it comes to larger networks like a full mesh or an MPLS cloud, where you have remote sites coming in through your ISP, if you still have kind of a single central interface, right, where all of your services, maybe all of your services are being provided by this network down here. So maybe all of your network storage is down in this place. All of your applications are hosted here, and everyone else, all your remote sites, are coming through kind of that MPLS cloud into your local LAN. Then yeah, you can still absolutely. Apologies again, everyone. It seems I'm having a few difficulties with drawing tools today, so I'm going to avoid using drawing tools. But if your services primarily are being provided by one of your LANs, then yes, you can still kind of do a single central interface on your primary router on that location and monitor your traffic both in and out to the internet, but also in and out to your remote sites as well. But if you really want to get a complete information, then you should be tracking all WAN interfaces, which means you'd be wanting to monitor your WAN interfaces at those remote sites. So for the small LAN, the GC LAN, the Gold Coast LAN at the top, and the Charlotte LAN on the left-hand side, you'd want to be monitoring the WAN interfaces on each of those locations as well. And you could, of course, if you have multiple switches, be monitoring the main link lines on those switches too. So we talk about the concept of having really kind of 4 base concepts to get the most out of NetFlow and IP-Fix. So I always recommend to any of my clients who start implementing opFlow, start small, because you have to work out a few things first. You have to work out how to configure your devices. So, what's the model and manufacturer of the router and switch that you want to use? How do you configure NetFlow? What version of NetFlow? Setting up the opFlow server, sizing the opFlow server. So start by focusing on just your WAN and your internet links, and then the interconnects to other rings as a starting point. So you really want to focus small, just a few interfaces to begin with. And then once you understand the information that you're getting and opFlow is processing information well, and it's handling the load on the server, you can start expanding that to include trunk links between switches for local LAN traffic. We often get questions on whether you should collect both ingress and egress information. I've actually had clients say, well, if you're monitoring the WAN or internet link, I don't really care. No one's going to send information out to something like Netflix, for example. My concern, though, is that not only are you pulling information in and consuming data, but you may be pushing information out from your network to locations that you don't want it to go to, right? People may be doing processing internally. We had a situation where a client contacted us. Their bandwidth was being used dramatically, and what was happening is a very well-meaning individual at the client site had actually installed SETI processing software on their laptop, and so they were downloading bits of information, processing it for SETI to try to find alien life forms, and then pushing that information up. And so they had dedicated a tremendous amount of processing capability on a laptop they weren't really using, but weren't paying attention to the amount of bandwidth that communication, both download and upload, were taking on the network. So just as an example for you. So yes, we do recommend collecting both ingress and egress information. We also strongly recommend that once you start configuring opFlow collection, that you watch your routers and your switches, the CPUs that are configured for NetFlow, that you watch their CPU usage closely, especially with older units or older versions of operating systems on them. It can really cause problems depending again on how many interfaces, how much time you're collecting, what your sampling rate is, how often you're sending the NetFlow and IP-Fix information. And again, how many interfaces you're doing, and how much flow is moving through that router. I will note while we're talking about flow through routers that opMantic offers two versions for NetFlow analysis. One is opFlow, and then we have a service provider version called opFlow SP, where the only difference, and I'll actually bring up the interface for opFlow in a moment, but the only difference is that when you go to the main dashboard of opFlow SP, it doesn't preload every interface into the dashboard at one time. It actually just gives you an agent selector, and then you have to drill down into a device before it will actually load and populate the dashboard. And the concept of that is just simply to keep the dashboard fast, responsive, and keep the system working quickly. The fourth thing that you really want to kind of wrap your mind around is the concept that you should be looking to analyze your NetFlow and your IP-Fix data locally to the LAN devices that are producing it. We've worked with a lot of very, very large multinational companies who, for whatever reason, they only have one NetFlow analysis server set up, and so they're having they're streaming NetFlow and IP-Fix data globally across their backhaul circuits, and they're just eating up bandwidth 24/7, pushing information back to this one central server so that everything's available in one pane of glass. So opMantic's opFlow system, we really recommend a different approach. Rather than having just one big, huge, expensive server, spin up multiple virtual machines, multiple VMs handling your NetFlow analysis, and then site those in your in the same regions where you might have your polling servers. If you're doing monitoring and fault analysis with NMIS and opMantic's other solutions, you might co-locate your opFlow servers in the same locations. I wouldn't recommend putting them on the same servers, but you could put them in the same physical locations, the same data centers, the same LANs. The concept being is that you won't be pushing all that data across your backhaul. You'll be analyzing it locally. You'll be dealing with it locally. That might mean that you have a couple of versions of opFlow that you can remote into when you're analyzing traffic in and out of that location. But what it really gets down to is saving yourself time and money on buying bandwidth when you don't need to. All right, so how do we leverage the opFlow interface? So let's take a few pictures here. So let's take a quick look at opFlow itself. So this is the main dashboard for opFlow. You'll see that it's configured to show the top conversations by application in the top right. Down the left-hand side, you'll see we have flow summary information. We also have our agent selector panel. This lists all of the different routers and switches that are actually sending flow information. We call them agents. You can drill into an individual agent. It'll give you a list of the interfaces, and then you can even select a direction if you want to differentiate between ingress and egress. And then at the bottom, we have a map of conversations. So you can see here, we've got a rather detailed map. We can organize it a bit. Take a look. The larger, wider lines that you see here, for example, this green set, and then down here, this red loop back on other, indicate much larger flows of information. If we drill into an agent, so for example, here's my agent, I can hit apply selection, and it's going to just give me all of the interfaces on that device that are sending flows. I'm going to select this Ethernet 00 uplink, and I want both ingress and egress, so I'm not going to select a direction. So now we're getting very detailed information. You'll notice that the screen has changed now. We're getting conversations by application at the top over time, and then at the bottom we're getting a breakdown by source, destination, application, and bytes. So we can actually resort this. You'll also notice in the top left-hand corner this blue button, interface performance graphs. If your opFlow server is configured to talk to an NMIS server with OP charts on it that has these devices, so this device is actually being monitored. We have live performance monitoring in NMIS. So I'm going to use my browser's ability. I'm going to right click on that button and hit open link in new tab. And so we can actually open that link and we can see the performance of that interface over time, including interface error packets, interface packets per second. And so we're going to get the ucasts, the errors, the out ucasts as well. All of that good rich information. And this is all interactive, of course. Now I just right clicked on that interface so that I could bring this up without having to go and backtrack back into opFlow. But opFlow is intelligent. It's going to actually remember these agent selectors for me. So I have a lot of things that I can do here. Not only have I now filtered down on a specific device, but a specific interface. I can define and filter on specific applications as well. So I've defined a couple of applications in my system, and I can actually filter on those applications. I can change my time period. So currently we're looking at about a 15-minute window of time, but I can certainly look into larger windows of time as well. Keep in mind, though, that depending on the number of flows that you have, the size of the interface, how much activity is going on, it could take several seconds for the screen to redraw and pull that information back from the server. This is a web application. The opFlow GUI is a web application, so it's not a desktop app. It doesn't have that kind of screaming fast connectivity to the server. Everything's going through HTTP. A few other views that are absolutely helpful here. We're going to go down. We're going to take a look at the conversation map. Now you'll notice that when this map loads, that it remembers the agent selector. So it remembers the filter that was selected earlier. And now I can actually break this information out. I can kind of organize this a bit and take a look. We can see that there's an awful lot of traffic going to and from these three devices here at the top now. There's quite a bit going down here too to this 0.6 device. And so we can come down, and if we wanted to, we could go further. So let's say that I wanted to do source. And let's say that I want to do 10.248.0.6, go. And now we can just filter that out as well. So it's very, very powerful to drill into these pieces. You'll see down at the bottom, we also have the ability to export to CSV as well. So lots and lots and lots of capability here. Quite a bit of customization can be done. We have several clients who actually use these types of views and add them to their NOC windows as well. So if you've got the big screen on the wall, this could be very helpful to you. So the next thing we're going to take a look at, the top end report. Again, notice that the top end report has still inherited the agent selector. So it's limited to just those interfaces. Now I'm going to clear that selection. So I've cleared my agent. So now this is everything now. And you can see that we can organize this by top applications, application sources, application conversations, top conversations, top listeners, protocols, talkers, and top TOS. So again, the concept would be to keep track of what applications are really using your network, right? So you can see here that many of these applications have been named. We've got different names in here for each of these, what SRC ports, how many bytes. These can all be filtered and searched through, of course. The last piece of the puzzle that we find very useful and super helpful is generating daily summary reports. Now, some people prefer to do this once a week. I like to do this once a day. So we've just defined a daily summary report for the last 24 hours. And the system is going through and it's going to give me all of this lovely information about the conversations that are happening by traffic, top applications, top talkers. And I've configured this report just to give me the top 10 for each of these categories. You can define which of these you want. Top listeners, top application sources, and the top protocols by traffic. But this can be absolutely helpful in kind of keeping track day to day on what's happening across your network. You can, of course, save this out as an Excel spreadsheet. I prefer to work with this live, just because while I'm in here, I can actually take information that's here and I can search for it through opFlow. I can analyze it. I can try to take a look at it. And of course, I can always go back to, since I have opFlow connected with NMIS, our performance fault monitoring system, I can gather information from there as well. All right, that concludes today's overview of using opFlow for improving network performance. I hope that this brief overview was helpful to you. If you have any questions, please check out opmantic.com. If you go to the products section, you can find lots of good information on opFlow, as well as links to our online wiki and resources. You can, of course, download a copy of opFlow and get a trial license for it as well, free of charge. Spin it up in your lab environment or your production environment and see how it works for you. If you have any technical questions at all, please feel free to reach out to me. Again, my name is Mark Henry. I'm a senior engineer here. My email address is markh@opmantic.com. Thank you for your time today.